Powerful collaborations, cutting-edge science, and curious minds coming together for a glimpse of the future. Stay tuned as we look at the latest updates on some of the most promising technology projects. Welcome to Spotlight on European Innovation. I'm your host, Peter Ballant from Technicon. Today we're talking about drones, but it's a side of drones you probably hadn't thought about before. Launching one drone is fairly straightforward, but what about launching 20 or 50 or even a larger swarm? In this scenario, the trick is to get them to communicate and make decisions amongst themselves a lot like animals would. It's no easy task, but for Christian Bettstetter, it's a career. He's a professor and head of the Institute of Networked and Embedded Systems at the University of Klagenfurt. He's also the founding scientific director of Lakeside Labs, a nonprofit company that performs research on self-organizing networked systems. He joins us today along with Agata Barciś, a PhD student and researcher in the Karl Popper Doctoral School on Networked Autonomous Aerial Vehicles at the University of Klagenfurt here in Austria. Together they wrote a paper entitled Beyond Sync, Distributed Temporal Coordination and its Implementation in a Multi-Robot System. This paper was submitted to the IEEE International Conference on Self-Adaptive and Self-Organizing Systems in Sweden and won the award for Best Paper. It's really a noteworthy achievement for this pair, and we welcome them to the studio to talk more about their work. We start with Christian Bettstetter by asking, what are you working on?
I'm working on networked systems, where these systems can be anything from tiny sensors to robots to cars or even larger systems like airplanes. One of my field of research is how to make them networked in an efficient, energy efficient, resource efficient manner. And I've devoted the last years to a special topic where we work on multi-drone systems, so multiple aerial robots. This topic we started 12 years ago, and we now have a new doctoral school in this area at the University of Klagenfurt, where we have 4 PhD students working on control of such aerial robots, on communication of such aerial robots, on synchronization and other aspects, localization, navigating them through space. Also, always with certain applications in mind, like drone delivery systems or inspection of industrial plants.
My first thought is this has a good side and this has a bad side. Can you just touch briefly on the good side? I think you just did, which is delivery services, for example. What would be the bad side?
The bad side. Many technologies can be used for the good and for the bad. My main area is wireless communication, which can be used for us, to communicate, to socialize, and can be also used for the bad side, for terrorists to communicate or for, let's say, aggressive military things.
Okay.
Most technologies have dual-use character, and it's the same for aerial robotics. The good things is really this, what I'm fascinated, aerial delivery, so that you get very urgent and important goods delivered by an unmanned aerial vehicle, for example, urgent medicine or other urgent things that are life-saving. And this is already done now.
Now, most people know what drones are, of course, but I don't know how many people really know what a drone swarm is. So this is many drones traveling together and communicating with each other. Do you see this as this technology being used for delivery service? For delivery, I see one drone, but is it possible that there are a swarm of drones delivering something?
Yeah, delivery service also has to be multiple drones that coordinate each other, like a taxi fleet. There are also multiple taxis that somehow have to coordinate who picks up whom, and what needs to be done after a person is delivered to some place. And the same is true for drone delivery services. There always have to be multiple drones that somehow coordinate each other. It doesn't have to look like swarm of birds or so, but there are always multiple entities that have to coordinate and communicate with each other.
Okay, and this is your field of study, exactly how this is done, the algorithms that allow these devices to communicate.
So one field of study is how the wireless communication is done, and the other field is how these entities, these drones, these robots are coordinated, how they, for example, synchronize in time, and how they do the swarming. And also the coupling between the two, how they might interact, how you could do sync and swarm at the same time.
Tell us about Lakeside Labs.
Lakeside Labs is a non-profit research organization that focusing on self-organizing networked systems. We have here 3 areas of expertise. One is industrial sensor networks, another one is multi-drone systems, and on the third one it's more a basic topic where we take a look at how to design self-organizing systems in technology, mainly in ICT and in transport systems. And self-organization means for us things like self-healing, self-optimization, self-configuration, those things.
Tell us a little bit about the funding that you received to do your research.
So in the drones area, we have a doctoral school that is funded by the university. This was a competitive process to get this doctoral school. And then we have, of course, a number of individual projects, for example, one on synchronization, on self-organizing synchronization, funded by the Austrian Science Fund. So that's some fundamental basic research. And also applied research, where we have Horizon 2020 projects on, for example, on swarms of cyber-physical systems. And these applied projects are always with companies, international companies, but also companies here in the region.
Thank you. Let's move on to Agata and tell us how you became interested in this area of technology.
So I was studying automation and robotics in Wrocław, and I was always interested in robotics. Like, since I was a little child, I wanted to be an engineer, and I was working in the company that was focused on Internet of Things, and I was embedded software developer. And then, like, as a continuation of my studies and my work, I was looking for some PhD offers in the field of robotics. I found a position in Klagenfurt in this doctoral school that was about drones and drone systems. And there were 4 PhD students hired, and we were split in 4 groups. So based on my earlier experience, I was assigned to this synchronization part. I didn't know almost anything about synchronization before I started, but now I really like this field, and this combination of synchronization and swarming lets me work with real robots, which is also important to have some experiments, and I really enjoy it.
You must be really good in your field because you just were awarded a best paper from an organization. Can you tell us about that a little bit?
Actually, this was my first published paper in the SASO conference, so about self-organizing and self-adapting systems. We were working on this distributed time coordination, and we decided that this is the paper that we can publish to the self-organization conference, because earlier we were also aiming at the robotic conferences, and we got some really good reviews, and lucky we were awarded with the best paper award.
Okay, and the paper is not yet published, but it will be soon. Is this correct?
I think it wasn't published when I was writing to you, but now it is published.
Okay, good. This organization is called the International Conference on Self-Adaptive and Self-Organizing Systems. What kind of organization is this?
So I wouldn't call it organization. It is more the conference, like one of the best conferences in the self-organization field. And as I told you, like, we are working somewhere between self-organization and robotics. So our aim conferences are in this field and also in robotics. So we have like 4 conferences that we can publish our work to, and this is one of them.
Okay. Yeah, congratulations on that. I think that's really quite an achievement. I didn't realize that that was your first paper also. So yeah, that's really great. Yeah. Can you speculate about what about your paper drew the attention of the organization?
I mean, in the paper reviews, there are some criteria like novelty and degree of innovation and writing style, and this was all evaluated by at least 3 experts. And then the decision for the best paper is made by a small committee, but mainly based on these expert opinions.
So in some of your papers, I read this term decentralized planning. This sounds like it's very important. What does that mean exactly?
We were working in with multi-robot systems, and our goal is to not have the single point of failure. So probably centralized algorithms for many cases are more efficient, but still there is this one point when it fails, the mission cannot continue. And when we have the multi-robot systems, we always think that any robot can join at any point or leave the swarm, and it shouldn't disturb the mission.
Okay.
So also, especially with drones, the mission area can be really broad. So this is possible that we cannot communicate with all the drones, and if there is some tasks to be assigned, we need to communicate only with those that we can reach, and somehow make sure that they will all have one decision, like who will do this task.
So what you're saying is if in a drone swarm, it's possible that you might lose 1 or 2 either communications or they just are no longer there. The idea is that the mission goes on, right?
Yes.
The show must go on.
So drones can start from 2 separate areas on 2 different corners of the mission field, and then they don't know that they all are starting the same mission, but when they meet, they should still continue mission together.
Okay.
I think that's one of the advantages in nature, when you have a swarm of animals, for example, that failure of one individual entity doesn't hurt the entire swarm. It still works.
And the same idea is adapted in this mechanical scenario too. Regarding drone swarms and the technology that you're developing, what would the average person expect to see? How will this help them?
I think one of the early use cases of multi-drone systems will be not for, let's say, for the general public, but more in industrial cases, in inspection of industrial plants, chemical factories, other things. Or in entertainment and art, where it is already done. If you search on YouTube, there are many of these drone shows already. So this is, in my opinion, a mix of entertainment, and it's also a new form of art, how to do aerial light shows with sometimes thousands of drones. What the disadvantage, what the difference to our work is that these drone shows at the moment are centrally planned. Each drone has a fixed path which they go. It's not adaptive to some changes. And our work is basically an online algorithm, and the patterns also emerge by the rules of the algorithm. So that's the difference. We could also do it with 1,000 drones if we would have them. This wouldn't be a big problem. The main obstacle here is regulation and safety.
Would you call this artificial intelligence, the work you're doing?
In a broad sense, yes.
I mean, it is adaptive, right?
But at the moment, we don't use learning for this kind of work. So aspects of machine learning are not included, but from a broad perspective, you could say that this is AI.
Mm-hmm.
From a very broad perspective.
In the perfect scenario, what kind of work do you see yourself doing in the future? I mean, is it continuing developing these algorithms and this technology for drone swarming, or is there a different level you would like to achieve?
There are different streams of work. One is to commercialize certain things that we are doing. So there are spin-offs in preparations by two of my PhD students. And in terms of research, at the moment, we have some very interesting industry collaboration with T-Mobile, now called Magenta, where we work on 5G connected drones. So how can you integrate aerial devices into cellular networks?
And you're sort of new in your career. What do you see for yourself in the next 10 years, for example?
So for sure, now I want to focus on finishing my PhD, and after this, like, it depends what will be the opportunities afterwards.
Okay. But this seems like it's a field of study that really appeals to you.
Yes, for sure. I like this field of study, and for sure I would like to connect somehow my future with robotics.
Yeah, some of the things we are talking about sound a little bit like science fiction, but in certain parts of the world, this is already reality. For example, this drone delivery is already done by some startup companies in Rwanda, where they deliver blood samples to hospitals, and they were able to reduce the delivery time significantly because the roads are not so good there, and if there are disasters, the roads are blocked, and with aerial delivery this can really save lives. And this is already done. Yeah, this is not something of the future. This is what many people also don't know. Yeah? So on the one side, some of the things we are working on really sound very scientific, yeah, but let's say in a more basic form are already realized in certain parts of the world. And also these drone aerial light shows really took off in the last few years. And you can now see thousands of drones in the air as alternatives to fireworks, writing something in the air or doing really some interesting artistic work. So I would really say that's a new form of art.
Well, it appears you both have your work cut out for you. I want to say thank you for taking the time to come in and talk to us today about your work, and we will see you soon.
Thanks for the interview.
Thank you.
This podcast has been brought to you by Technicon.